So I'm going to talk about the inventory cost model, and the problem is this. Suppose that a company needs 1,200,000 items during a year, and the preparation for each production run costs $500. Suppose also that it costs $24 to produce each item and $3 per year to store an item. Use the inventory cost model to find the number of items in each production run so that the total cost of production and storage are minimized. Okay, because we have the keyword minimized, that means we're going to be finding the derivative. That's an I. And we're going to be setting that derivative equal to 0 and then solving for x. Okay, so the first thing that we need to do is figure out what is the formula for the total cost. Now, we have three things that are costing money. It's going to cost money to do a production run. It's going to cost money to produce the items. And then it's going to cost money to store those items since we can't sell them immediately, right? They're going to have to sit in a warehouse somewhere. Okay, how do we figure out how much a production run or how much the production runs are going to cost? That's going to be the cost of each production run, which is $500, times the number of production runs that we end up doing. You might be wondering, how do we figure out how many production runs are we going to do? Well, it's going to be the total number of items, 1,200,000, divided by x. And x is going to be number of items in each run. So if we take the total number of items, 1.2 million, and divide that by the number of items each time we run a production run, that should tell us how many production runs we're going to have to do altogether. So that's how we came up with 1.2 million divided by x. Okay, then the next part of this cost function is how much does it cost to produce each item? And this is actually just going to be a number because we know each item costs $24 to produce, and we're producing altogether 1.2 million items. And that's going to be added to the final cost. It's like the raw cost of all the items. It's going to be 288 followed by 5 zeros. 1, 2, 3, 4, 5. So that's like $28 million just to make the items. And then we have to figure out how much is it going to cost to store these items. How much does it cost to store items? It's going to be $3 per year per item times the number of items that we're storing at any given time. And we have to kind of make an assumption here that the number of items that you're storing at any given time is going to be about half the number of items in each production run. And the reason for that is that if you produce, for example, 200 items and then you store them in your warehouse and you start selling them, as soon as you run out, you're going to have to produce 200 more and then you'll start selling those. Okay, so on average, at any given time, you would have 100 items in the warehouse. And so that's just an assumption that we're going to have to make, and that's going to carry over to other problems like this. So the number of items that you're storing at any given time is going to be about half the number of items in each production run. So we're just going to say that this storage cost is going to be $3 times x over 2. Okay, we're going to simplify all of this into something a little more manageable. This is going to be a very large number, 6 followed by 8 zeros, plus 3/2 of x, plus the 28,800,000. Okay, now this should be the total cost for X number of items in each production run. I'm going to go ahead and erase the rest of the stuff here. You can go back if you need it later. Okay, so we kind of get back to this, right? We're actually trying to minimize the cost. So what we're going to do is we're going to take the derivative of our cost function, and we're going to set it equal to 0. Oh, actually, I'm going to rewrite this cost function one more time in a little more manageable fashion. I'm going to change this to x to the negative first power plus 3/2 of x plus 28,800,000. Had to fit it on 2 lines. I'm sorry. Okay, so when we take the derivative of this function, we're going to get negative x to the negative 2 plus 3/2. And that's it. The 28 million, the constant at the end, that turns into a 0. So this is what we're left with. And then we set this equal to 0. I'm going to rewrite this in a little more manageable fashion. And I'm going to turn this negative exponent back into a fraction. So it's going to look like this. Okay, then we subtract 3/2 from both sides. We can get rid of the negatives because they're both negative. We can multiply both sides now by x squared. We can multiply both sides now by 2/3. That kind of gets rid of this. 2/3 of 6 is 4, so and then we square root this number, and we're going to get 20,000. So that means to minimize the production and storage costs for this scenario, each production run needs to have about 20,000 items. And that's the answer.